So the last unit is chapters 1, 2, and 3. And this stuff is, I would say, the easiest material that you learn in Math 10C. And that's part of the reason why it's saved till last, because if we're short for time, it's much easier to go through this material quickly than it is the other stuff that we've done. So this is the easiest stuff, the easiest material that you're going to see in this course. So it is a chance for you all to bring up your marks, right? Because at the end of chapter 3, we'll have our last unit exam. And there's a chance for you to bring up your marks. However, you probably still want to make sure that you're doing some of the practice so that you know what you need to do when it comes time for our quizzes and our tests. So this first chapter deals with measurement systems. So we're going to learn about the two different measuring systems. You're all familiar with the System International, the SI, or the metric system, right? That's the one that you guys have used throughout school, but it isn't always the measuring system that was used here in Canada. Okay, I think I might have been grade 5 or 6 or something when we changed from the imperial system to the metric system. The United States still uses the old imperial system. England, the UK, still uses the old imperial system. But most everywhere else in the world uses the metric system. And for places like the US, it would cost a massive amount of money to switch over because everything would have to be switched. Every time you're driving down a freeway in the US, all the distances are in miles. Well, those would have to be changed to kilometers. All the advertising, whether they're advertising things in length or mass or anything, it would all have to be changed over. So all the packaging, manufacturers that manufacture and sell goods, all their packagings would have to be changed to display the new measuring system. So it would be a massive, massive undertaking. I mean, our country, Canada, is just over 30 million people. The US is over 330 million people. So it's much more populated, much more business stuff going on. It would just be that much more to do the changeover. The trades industry, though, still uses the old imperial system. If you go to a lumber store to buy lumber, the most common piece of lumber is a 2x4. It's a piece of wood that's approximately 2 inches by 4 inches. So that's the old imperial system. Those are sold in 8-foot lengths, and 10-foot lengths, and 12-foot lengths. Again, that's the old imperial system. Pipe is usually sold or measured by diameter in inches. 1-inch pipe, 2-inch pipe, 3-inch pipe, half-inch pipe. Same thing with some of the bolt and nut sizes. They're also commonly in terms of the old imperial system. So if you ever get into a trade, then you probably will use the old imperial system extensively because that's what they use. So again, we're going to talk about measurement first. That's chapter 1. We're going to talk about the two systems, imperial and the metric system. We're going to be converting between the two as well. That's chapter 1. Chapter 2, we're going to do surface area and volume of shapes. And then chapter 3 will be trigonometry, which is looking at triangles. We're going to see how we can find missing angles and missing sides in right triangles, a 90-degree triangle. Okay, Brooklyn? All right, so let's start with measurement. This first question says, use the ruler on the left to measure the width and the height of the painting. So I've got a ruler here, and this is a ruler that's in centimeters. You can see right on the ruler it says centimeters. So if you were using a ruler on your page, because the scale will be a little bit different, the picture that you see on the smartboard or on the TV is bigger than what you'd see probably on your page. But anyways, when I use this ruler, which is in centimeters, we can see that it is 7 point, and it looks like closer to 7.2 than 7.1 high. So we'll say 7.2 centimeters high. And the width looks like it is about 9.2 centimeters wide. Right, so that's how we use a ruler. And centimeters, metric rulers are usually easier to work with because we're going to see that the metric system goes in increments of 10 units. So there are 10 little tick marks between 0 and 1. So that makes it easy, to use some fairly close accuracy on these rulers to measure. This next page says that the actual dimensions of the oil painting of Van Gogh's Starry Night are 10 times as long as the dimensions shown in the diagram here. What are the actual dimensions of the painting? So it's the same painting, right? The width is 9.2 and the height is 7.2. So the width would be 9.2 centimeters times 10, because the actual dimensions are 10 times as long as the dimensions in the diagram. So that would be 92 centimeters. And the height, which was 7.2 centimeters on the diagram, is also 10 times, which would be 72 centimeters. So this introduces something known as a scale factor. A scale factor is used to talk about whether an object is enlarged or reduced by a certain scale factor. And so that scale factor is a number that all the dimensions are multiplied by. In this case, because it's just a picture, there's only two dimensions there, the length and the width, or the width and the height. So both of those are multiplied by the scale factor. We're going to see some cases later on where we might have three dimensions, where it's a three-dimensional object. Well, again, you would multiply all of the dimensions by the scale factor. So in this case here, this would be a scale factor of 10, because that's what all the dimensions are multiplied by. We mentioned briefly something known as a referent. A referent is where you have an object that you know the dimension of it, and then you can use that in order to estimate what its dimension is. Okay, so for this case here, you could use the width of a dime. A dime, I think, is about a half an inch wide. Okay, and you can lay out dimes on this rectangle and see that it is 5.5 dimes wide. If each dime is a half an inch, then the actual width of the rectangle could be approximated by going 5.5 times a half. So this is the whole idea of a referent, which we will talk about from time to time. So again, we're talking about the System International and the metric system. So today we're going to focus on the international or the metric system. The other one is the old imperial. As it says on the right, it's a system of measurement in which all units are based on multiples of 10. The meter is the basic unit of length. So if we look at this table here, and we start in the middle, which the meter is the basic unit of length, a decimeter is 10 times a meter. There are 10 meters in a decimeter. A hectometer, there are 100 meters in a hectometer. And a kilometer has 1,000 meters. And that's why that's the multiplying factor. If you're going from meters or kilometers down to meters, you would multiply by 1,000. If you're going from hectometers down to meters, you'd multiply by 100, and so on. Now, as we get smaller, A decimeter is 0.1 of a meter. A centimeter is 0.01 of a meter. And a millimeter is 0.001 of a meter. So we're going to use this along with something that we're going to introduce called a metric staircase that we can use to convert within the metric system. But before we talk about that again, we'll mention this referent again. It's an item that an individual uses as a measurement unit for estimating. For example, if the height of a doorknob above the floor is about 1 meter, well, you could use that as a reference. You could compare something to the height of a doorknob to estimate what its height is. Or the thickness of a dime, thickness, not width like we talked about above, thickness of a dime is about 1 millimeter. So you could use that to estimate how thick something else is. Various measuring instruments allow accurate measurement of distance in standard units, but we can also develop these personal reference to use when estimating measurements. The most common referent probably people use is a person's stride. If you're walking, a full stride is about 3 feet long, or about a yard long, which is approximately a meter. So that is probably the most common referent. You can estimate how far something is by stepping it off. Okay? A person's stride is approximately a meter, or approximately 3 feet, which is a yard. Now, obviously, depending on how long your legs are, some strides are longer than others, but this is an average for an adult. Okay? So that's probably the most common referent that exists, that people use often. So, example 1 says, estimate each distance using an appropriate referent, then measure. So, what we will do here is we'll just talk about what referent a person might use. The first one would be a thickness of a CD case. Well, we saw just on the previous page that a dime is about 1 millimeter thick. So you could use dimes. You could stack up dimes beside a CD case and see how many dimes high that CD case is as far as the thickness goes. And each dime is 1 millimeter thick. So that would be something that you could use for estimating the thickness of a CD case. So for A, we would use dimes. They are 1 millimeter thick. So that would be a good reference to use for guessing or estimating the thickness of a CD case. The height of the seat of a chair. So maybe a good reference that you could use for this is you could take a ruler and you could measure, let's say, how high or how long it is from the floor to your knee. That would be fairly close to the height of a chair. But if you knew how many, let's say, centimeters it was from the floor to your knee, you could use that as a referent for something like the height of a chair, or something that's fairly close to that distance from the floor to your knee. So a good referent to use here might be use the length from floor to knee. Now again, you'd have to get a measuring stick, a ruler of some kind, or a meter stick to measure that first. And then once you know what that distance is, you could use that to estimate. The width of this page, well, there's a couple different things that you could use. You could use the span of your hand. If you, again, spread out all your fingers and you measured what the distance is across from your little finger to your thumb, that's your hand span. If you knew what that measurement was, you could use that as an estimate. Now my hand almost goes right across my page here. So it would be a very good reference to use. 1 hand span is the width of this page. Okay? But there you could use anything you wanted to. You wouldn't want to use anything that's really, really small. Like if you had 100 things to go across the page, that wouldn't make sense, or something really, really large. Okay? But again, you could use your hand span, if you knew what that was, to measure something, even like the top of the desk that you're sitting at. You could use that. Okay, Riley? All right, so those are just some examples of how this works. All right, example 2 says a newspaper reported the following measurements in different stories. It says the distance from Earth to the moon is 38,440,300,000 centimeters, and a worm measures 0.0019 meters. So we want to get a more appropriate unit that would be used and then do the conversion. So this is where our metric staircase is going to come in. So I'm going to go back to that previous page, and then I'm actually going to add a new one in there. And let's make this metric staircase. So there should be 7 steps on the staircase. And each step will represent one of those units that we saw on that chart. We'll start at the top. Actually, let's start in the middle. The middle is where our base will be. It might be in meters if we're doing length. It might be liters if we're doing capacity, or it might be grams if we're doing mass, if we're measuring how heavy something is. So we'll start there. There are 3 measures or 3 units above the base, which is our meter, and there are 3 that are below. And if we look back a couple pages, that's what those units are. You're going to have kilometers, you're going to have hectometers, and you're going to have decameters. So you see the abbreviation. Kilometers, HM for hectometers, DAM for decameters. So let's put those on our metric staircase. So kilometers, hectometers, DCA for decameters. And if we go back, actually I need to write DAM instead of DCA. That's fine. Doesn't matter. We'll leave it like that. The next ones below the meters are the decimeter, the centimeter, and the millimeter. So DM, CM, and MM. Maybe I'll go DCI, just so we are clear. The first one, the one higher than the meter is the deca, and the one below the meter is the deci. So far, it's not really anything that wasn't on that chart that we've been referring back to. But here's what we're going to add. If you're going from kilometers down to meters, if you have a 1 kilometer, that's 1,000 meters. So as you go down the metric staircase, if you're converting, your values are going to get larger. Again, if you go from kilometers down to meters, if you have 1 kilometer, that's 1,000 meters. So as you go down the metric staircase, your numbers will get larger. And as we said earlier, that the reason why the metric system is so popular and easy to use is because everything is based on factors of 10, meaning every time you go down 1 step of the staircase, you're going to multiply by a factor of 10. If you go from kilometers, there we go, to hectometers, you're going to multiply by 10. If you're going to go from kilometers down to decimeters, you're going to multiply by 10 twice. You're going to multiply by 10 times 10 or 100. And if you're going to go from kilometers down to meters, you're going to multiply by 10 3 times. 10 times 10 times 10, which is 1,000. Like we said, there are 1,000 meters in a kilometer. If you're going up the metric staircase, though, now you're going to divide by a factor of 10 every step that you take. Okay? So, we will use this to answer these questions. If we want to go from centimeters to what is a more appropriate answer or unit, well, 38 billion centimeters doesn't make sense to report that distance in centimeters. Because it's such a big number, we would want to use the largest possible unit, which would be kilometers. So we want to go from centimeters to kilometers. So again, for each question it says state a more appropriate SI unit. So we're going to use kilometers. And then to convert from centimeters to kilometers, we're going to refer back to that metric staircase. To go from centimeters to kilometers, you're going up the staircase, Jan. And as we go up the staircase, you're going to divide by another factor of 10 every step. So count the number of steps from centimeters up to kilometers. And you won't start counting until you move. So moving from centimeters to decimeters is our first step. That's one step. Then to meters is 2. Deca is 3. Hecto is 4. Kilometer is 5. You're going to go 5 steps up the metric staircase, which means you're going to divide by 10 5 times. You're going to divide by 10 to the power 5. And 10 to the power 5, if you do that on your calculator, is 1 with 5 zeros. You're multiplying by 10 5 times, which means you've got 5 zeros. So you're going to divide by 100,000. So it's 38,440,300,000 divided by a 1 with 5 zeros. And whenever you divide by 10, just 10, the decimal moves 1 spot to the left. If you divide by 100, the decimal moves 2 spots to the left because there's 2 zeros in 100. So if you're going to divide by 100,000 and there's 5 zeros there, you need to move the decimal 5 spots over to the left, which will take us between the 3 and the 0. So that is 384,403 kilometers. There's a more appropriate unit to use for that measurement. And for the second measurement, you have a worm that measures 0.0019 meters. I'm going to say this is B. We've got 0.0019 meters. So in this case here, I would probably use millimeters. I'm going to go from meters down to millimeters. So if we look on our metric staircase, from meters down to millimeters, we're going down the staircase, so you're going to multiply by 10. You're going to multiply by 10 every step you take. So to go from meters down to millimeters, you're going down 1, 2, 3 steps. You're going to multiply by 10 to the power 3. So we will take this 0.0019 and multiply by 10 to the power 3. 10 to the power 3 is 1,000. It's 1 with 3 zeros. If you're multiplying by factors of 10, the decimal goes to the right every factor of 10. So we're going to have to go to the right 3 times in this case. 1, 2, 3. The answer is 1.9 centimeters. Sorry, millimeters. 1.9 millimeters is the length of that worm. All right? So these next ones, we want to convert to a unit that makes more sense. For question A, I would probably use centimeters. I would convert from millimeters to centimeters. So if I go back to the metric staircase, to go from millimeters to centimeters, you're going up the staircase once. That means you're going to divide by 10 once. That means you're going to move the decimal over to the left once. Your answer has to get smaller. So that would be 20.5 centimeters. The ones that are used most often are the kilometer, the meter, the centimeter, and the millimeter. So unless we're specifically told to use one of the other ones, we'll always go to one of these. These are the ones that are most commonly used. So the next question, question B, the circumference of a highlighter is 0.06 meters. So for this one here, again, I'll probably use centimeters here. So 0.06 meters, and we want to convert that to centimeters. If we go back to our staircase, we're going to go 2 steps down the metric staircase to go from meters down to centimeters, which means we're going to multiply by 10 twice. So we're going to multiply by 10 squared, which means the decimal is going to move 2 to the right, and that'll be 6 centimeters. There's the answer for that one. Question C, you travel 590,000 meters from Regina to Winnipeg. I would use kilometers here. Take 590,000 meters, and now we're going to have to divide. We're going to have to divide by 10 3 times, because to go from meters up to kilometers, it's 3 steps up the staircase, and every step you're dividing by another factor of 10. So because we're going 3 steps up, we're going to divide by 10 cubed, which moves the decimal 3 spots to the left, and we'll get 590 kilometers. The last one, the door is 2110 millimeters high. I would probably use meters for this. So if you have 2110 meters, and you want to, millimeters, and you want to convert that to meters, to go from millimeters up to meters, you're going to divide by 10 again 3 times, because that's how many steps it is from millimeters up to meters. You're going to divide by 10 3 times, or divide by 10 cubed, which means the decimal is going to move 3 spots to the left. That'll give us 2.11 meters. Okay? So this metric staircase will not be given to you. So if you're going to use it for a quiz or a test, you're going to have to be able to recreate that. Okay, example 3. Kyla buys an oversized wooden barrel. She cuts it in half to make a planter. She wants to place a metal band around the planter 4 centimeters from the top to hold the planter together. So that's what this picture shows. Here's the metal band right there. She cut the planter in half, but she needs this metal band to keep it all together around the top. So she places that, it says 4 centimeters from the top. So that's the distance there. 4 centimeters from the top. If the radius 4 centimeters from the top of the planter is 0.6 of a meter, what is the length of the band that she will need? So we need to know what we want to find the circumference of the planter at that level. The circumference is the distance around a circular object. And that's what we want to find here. And we have a formula for circumference. And you'll be given a formula sheet with formulas on there. We can either say that circumference equals pi times the diameter, or 2 times pi times r, the radius. You see, the diameter is twice the radius. So if you change or you replace d with 2 times r, and then the formula is always written with pi in between the 2 and r. But remember, it doesn't matter what order things are multiplied in. When you multiply things, order doesn't matter. So it's just normally written in that form, 2 pi r. So those are the two formulas for circumference. And we are told, again, that the radius at this point is 0.6 of a meter. So we'll use 2 times pi times r. 2 times pi times 0.6 of a meter. Because we're told that the radius is 0.6. So when we use our calculator, most calculators have a pi button on them. On my calculator, it's above the power key. That last column, the very last row of the last column, above that you can see the pi symbol. Pi is approximately 3.14, but we will use the pi function in our calculator because it is an exact value. And we always want to keep numbers in our calculator and only round off our final answer. Now in this case here, your final answer will be the one we get here. So 2 pi, when I just go 2 pi, it means 2 times pi times 0.6. There's the answer, 3.7699. Now what does it tell us to round to? To the nearest centimeter. This number that we got here is in meters because I used 0.6 of a meter, 3.7699. And that is in meters. Notice that the question wants us to give it to the nearest centimeter. So we have to go from meters to centimeters, which means you're going to multiply by 10 twice. Because if you look on the metric staircase, it's 2 steps down from meters to centimeters. So you're going to multiply by 100, again, move the decimal 2 spots to the right. And when we round it to the nearest centimeter, it'll be 377 centimeters. There's the answer to that. Okay, so there's part A. Part B. If the bottom band of our planter is 1 meter shorter than the top band, what is the radius of the planter at the bottom? So that bottom band is 1 meter shorter. Its circumference is 1 meter shorter. We found our circumference at the top to be 3.7699. This one is 1 meter shorter. So I'll take that 3.7699 minus 1. Which is approximately 2.7699. That is the circumference of that bottom band. We want to find out what the radius of the planter is. So again, our formula for circumference, it's 2 times pi times r. Our circumference is 2.7699. That equals 2 pi r. So to find out what r is, we're going to solve for r. We will divide both sides by 2 pi. and that'll give us r by itself. But I want to get that number in my calculator. So I've got the 3.7699. We subtracted 1 to get our 2.7699, and that needs to be divided by 2 pi. And when I do this, I need to put the 2 pi in brackets to keep them both on the bottom. If you don't put them in brackets, if you just go divide by 2 pi, it'll divide by 2 and multiply that answer by pi. You'll get an answer that is over 9 times bigger than it should be. So that's why you put that in brackets. And r, our radius, and again, this is in meters, is 0.4408 meters. And if we want to express it to the nearest centimeter, we would multiply by 100 again. So approximately 44 centimeters. Because it's 2 steps down the staircase from meters to centimeters. So you're going to multiply by 10 twice. You're going to multiply by 100. What is the difference between the radius of the planter at the top and the radius at the bottom? So we need to subtract these two. So our radius at the top was 0.6 of a meter, which is 60 centimeters, minus the 44 centimeters. So that's what we need to do for part C. It's 0.6 of a meter, we were told, minus, and we can use the 0.408, but it does ask us to write it in centimeters, so let's use centimeters. And again, it just means we have to convert this 0.6 meters to centimeters. And so that is a difference of 16 centimeters. That is the difference between the two radii. Part D says, show how much the radius of any barrel increases if 1 meter is added to the length of a band. State it as an exact value, then to the nearest centimeter. So the length of the band is the circumference of the circle. So the length of the band, again, is the circumference. And the formula for circumference is 2 pi r. That's given. That's what we know. If 1 meter is added to the length of the band, so our circumference is going to increase by 1 meter, we're going to show how much the radius increases. So we're going to add 1 to the circumference. So again, what this says is that if 1 meter is added to the length of the band, we want to show how much the radius increases by. So we will put r plus x there because we want to know what that increase is. So x will represent the increase. Okay? So next I will multiply out the brackets on the right. It'll be 2 pi r plus 2 pi x. I'm multiplying out the brackets on the right. However, remember that we know that c, the circumference, is equal to 2 pi r. We've used this equation a couple times today. C is equal to 2 pi r. So this 2 pi r in our equation that we're working on right now can be replaced with c. So this will be c plus 1 equals c plus 2 pi x. And then you can subtract c from both sides, and they are going to cancel. So 1 will equal 2 pi x, and then we will divide both sides by 2 pi to get x by itself. So x will equal 1 over 2 pi. That's the increase in the radius if we add 1 onto the circumference. Now, again, that would be in meters. So if we go 1 divided by 2 pi, again, you want to put the 2 pi in brackets. There's our increase in radius in meters. So x is approximately 0.159 meters. And so if we multiply by 100 to turn it to centimeters, it would be approximately 16 centimeters. That's what it goes up by. Okay, I'm going to stop there. You should work on these questions on page 17 to 21. I will put the solutions in Google Classroom so that you can check your answers.